So hello students, in today's video I am going to discuss three topics, namely the angular velocity, torque and angular momentum from the chapter System of Particles and Rotational Motion. So basically this video will be useful for both class 11 studying students as well as students who are preparing for JEE and NEET. So basically the first thing what I'm going to explain is that term angular velocity. Now angular velocity, as we know, is the rate of change of angular displacement. Rate of change in angular displacement. Okay, but let's see what are its physical implications. Now say for a rigid body, some rigid body, and say this is the Cartesian coordinate system, this is x-axis, this is y-axis, and this is z-axis, and this body is rotating about this z-axis. Okay, now suppose this is some particle p, okay. Now if this rigid body is rotating about this axis, this particle will move in a circular path. Okay, now let's say its position vector is r. R is the position vector. Okay, now this, since it is rotating, so this particle p is rotating in a circle. This rigid body is rotating about this axis. So this is the velocity vector, and it is directed inward. Okay, so now if I bring these things over here, so this radius vector, it is directed outward, and the velocity vector, it is directed inward. Okay, so after some time, say after some time delta t, this point P reaches at this particular location by moving through an angle delta theta. So this angle is delta theta, this angle is delta theta, this is the new position P prime. Okay, so it has gone from this position to this position by describing angular displacement delta theta in time taken is delta t. Okay, so how do we define instantaneous value of the angular velocity? As omega is equal to delta theta by delta t. Omega is equal to delta theta by delta t. Okay, now this is one way of expressing the angular velocity, but we also know that v is equal to omega cross r. Okay, v is equal to omega cross r. So as you can see, if this is the direction of v, this is the direction of r, v is perpendicular to the plane containing omega and r. Omega has also got a direction. It is along this axis. Omega is, so if a rigid body, it is rotating in this direction, in counterclockwise direction, then the direction of thumb will give you the direction of angular velocity, omega. Similarly, if I change the sense of rotation, so if the rotation is in this direction, the thumb, it is in the downward direction, so the angular velocity will be in the downward direction. So let me represent this with the help of figure. So this is a disk, and this is the axis of rotation. So if the rotation is in this direction, then omega is, this is the direction of omega. Okay, and similarly for the same disk, if rotation is in this direction, omega will be in this direction. this is omega. Rotation is like this, omega is directed in this direction. Okay, so this is the relation between V, omega and R. So now from this discussion, what is our observation? That angular velocity describes the speed of rotation, because it gives information about angular displacement per unit time. So it gives the speed of rotation and orientation of instantaneous axis. That is the axis of rotation. Okay, now there is another important observation. Suppose this is x-axis, this is y-axis, this is the origin O, and this is some point P which is defined by position vector R. This is, let's say this angle is phi. So this point P defined by position vector R. This is the x-axis, y-axis. Now suppose this point P is having a velocity V in this direction. So now this velocity V will have a component V parallel. V parallel means this is the component velocity which is parallel to R, and this is V perpendicular. So this is the component of velocity which is perpendicular to R. Okay, so now this V parallel will not contribute to the angular velocity. Why? Because this, see, if point P, for this, suppose this pen, it is fixed about this point. Now if this point starts moving in this direction, that will not give any rotation motion to this pen, because suppose if this point is removed, and if you, for this rigid body, this point is given a velocity in this direction, it will move in this direction, so there is no rotation. But if this point is given some velocity in this direction, so it will give rotation. Okay, so that means only that component of velocity which is perpendicular to R, position vector R, only that component will provide the angular velocity. So angular velocity of particle P with respect to origin O is determined by perpendicular component of V. Okay. Achha. Now another important thing is, see, this I have given in my previous video also. Now in case of pure rotation, all the points on this rigid body will have same angular velocity. In pure rotation, each part of a rigid body have same angular velocity. So these are the concepts which you need to be very clear with reference to the topic angular velocity. Next topic of discussion is moment of force or torque. Now basically, suppose this is a rod and it is fixed at this particular point. It is fixed at this particular point. This point it is fixed. Now, if I pull this part, it won't move. Okay, but if I exert a force in this direction, it will rotate. It will rotate like this. It will rotate like this. So this turning effect, see, when I am applying a force such that it is producing a turning effect. It is producing a turning effect. So that is called torque. Now basically, torque is rotational analog of force. First observation is, see, force produces translational motion and torque produces rotational motion. So torque is rotational analog of force. Force, it produces translation motion, and torque, it produces rotational motion. Rotational motion. Okay, now first let us discuss this moment of force or torque for a single particle. Okay, now this torque, it is represented by the symbol tau, Greek letter tau. Okay, so I will calculate the torque for a single particle. Now suppose you have a Cartesian coordinate system and this is some particle P and this is the origin, x-axis, y-axis, z-axis. So particle P is defined by position vector r. It is defined by position vector r. Now suppose this particle is acted upon by force F in this direction. So this force will have a component F parallel. F parallel means component of F which is parallel to R. And there is another component of F perpendicular. Now F perpendicular is the component of F which is perpendicular to R. Now as we have seen, see this F parallel, if point P, on point P, if F parallel acts, it will produce a translation motion. Particle P will move in this direction. But if F perpendicular acts on P, the point P will move such that it will have a rotational effect with respect to the position R. It will move like this. So it will have a rotational effect. So that means F perpendicular is responsible for torque. So F perpendicular will produce torque. Now how do you measure it? Torque, it is the product of magnitude of R and magnitude of the perpendicular component of force which is perpendicular to R. So if this angle is theta, this is F, this will be F cos theta, this will be F sin theta. So F perpendicular will be F sin theta. So tau will be RF sin theta, or I can write tau is equal to R cross F. Tau is equal to R cross F. So this is the magnitude of torque acting on this particle P with respect to point O. Okay, torque is always calculated with respect to a reference point. So this is the torque for a single particle. So as the torque is the moment of force and it is R cross F and it is the rotational analog of force. Similarly, moment of momentum, it's also called angular momentum, is the rotational analog of linear momentum. Okay, so this is rotational analog of linear momentum. Now it is denoted by the symbol L. This is a symbol for angular momentum. Now, similar to the concept of torque, suppose this is x-axis, this is y-axis, and this is z-axis, and this is point P, this particle of which is located at point P, which is defined by vector r. Now, suppose the mass of this particle is m and it is moving in this direction with velocity v, such that its momentum is mv, linear momentum is mv, is equal to p. Okay. So, as in the previous case, I can express the concept of this mathematical form of this angular momentum in two ways. How? Now, suppose if I extend this line, this angle is theta. So this component will be P parallel and this component will be P perpendicular. So P parallel is the component of momentum which is parallel to R. Similarly, P perpendicular is the component of this momentum which is perpendicular to R. So now I need to take which component? As in the previous two cases, I'll be taking the perpendicular component. This component is responsible for rotational motion. Okay, so angular momentum, it will be product of R into P perpendicular. P perpendicular is the component of momentum which is perpendicular to R. So L is equal to R into, if this is P, this is theta, this will be P cos theta, this is P sin theta. So R into P sin theta. So L is equal to R cross P. This is one way of expressing the linear momentum. Now, see, in this case, I took the component of P. I can also take the component of R. Same case, X, Y, Z. So this is point P, which is defined by this vector R. It is moving, point P is moving in this direction, and its linear momentum is P. This angle is theta. So this is R parallel and this is R perpendicular. So R parallel is the component of R which is parallel to P. R perpendicular is the component of R which is perpendicular to P. So now for this case, I will take the perpendicular component to P. So L is equal to R perpendicular into P. So L is equal to, if this is R, this is theta, this will be R cos theta, and this will be R sin theta. This is R cos theta. So I need to take this component. So that is L equal to R sin theta into P. So L is equal to R cross P. Okay, so this is mathematical form for angular momentum due to a single particle. Okay. Now the thing to be observed is, with reference to this, is for single particle, this angular momentum L will be equal to 0 if one thing is momentum is 0, momentum of the particle is 0, or the particle is at rest, or this point P, this momentum, point P of, so this momentum P is such that it is passing through origin, means it is along this line. Momentum of the particle is along this line, along this line or along this line. In that case, theta will be 0. So that is momentum of the particle vector P passes through origin. That is theta is equal to 0 degree or 180 degree. So for all these cases, the angular momentum will be 0. Okay, now let's see. So we have L equal to R cross P and tau is equal to, we have L is equal to R cross P and we have tau is equal to R cross F. Okay, now let's see the relation between tau and L. So L is equal to R cross P. Now let's differentiate this quantity with respect to time. So basically we are finding the rate of change of angular momentum. So dl by dt is equal to dr by dt cross p plus r cross dp by dt. So this is dl by dt is equal to v cross momentum is mv plus r cross dp by dt is f, rate of change of linear momentum is force. Now this is v cross mv. mv is a scalar quantity, so basically this is m times v cross v, that is 0. This is 0. So we have dl by dt is equal to r cross f. Now what is r cross f? R cross f is tau. So we have tau is equal to dl by dt. So that is torque is equal to rate of change of angular momentum. Now this is analogous to the force. We have force is equal to dp by dt. That is force is equal to rate of change of linear momentum. So similarly we have torque equal to rate of change of angular momentum. So we can say that this is the Newton's second law, Newton's second law in translation. And similarly we can say that this is the Newton's second law in rotational motion. So these are the few things which I wish to discuss with you all. So basically in today's video I have discussed the basic concept of angular velocity, the basic concept of torque on a single particle, angular momentum of a single particle. Now the things related to the rigid body will be discussed in the next video. And if you have any doubts related to the things which I have discussed in this video, you can post in the comment box. Thank you.